in case of reflection? Yes,
So it would be virtual and direct.
of course. It will be virtual and erect, and it will be on the opposite side of the lens. Like I'm talking about the opposite side of the mirror. What exactly I'm saying? On the back of mirror. Now, see what exactly it is. I want you to have your pencil and a scale ready for this. Let's suppose this is your mirror. This is the other surface which is not polished, and this one is a polished surface. Okay. Let's suppose this is your object. No, no, this is a bit far. This is your object. So when the something is striking that object, it will strike here and it will reflect back with the same angle. How do you know this? Angle of incidence must be equal to angle of reflection. So whatever angle you select, it should be equal. Angle of incidence and angle of reflection. Okay. Now with the same line, with the same, object, you will draw another angle of incidence, anyone, and when it will reflect with the same angle of reflection. Let's suppose you select 40-degree or 50-degree, and then you reflect it back with the same angle. Same thing, you will select this time some other angle, and you reflect it back with the same angle, right? Everyone, please draw it and send me the screenshots, everyone. Okay? I'll be waiting. And then what you do, because it will not be coming anything, you will not get any angle or any reflection or anything. Remember one thing, we already know that the image which is formed on the mirror, the plane mirror, it will be at the same distance from the mirror and it will be of the same height. So what you do, you will reflect it back. We will proceed it backward like this. When you reflect it back, it looked like it is coming from the same point. So it is my distance is definitely a bit smaller, but when you draw it, you should draw it in the middle. So this distance and that distance will be same, right? And exactly the opposite side of the mirror. Your image will be formed at the back of the mirror, which is actually not possible, but definitely it will form at the back of the mirror. Can anybody please draw that image and send me the screenshots, everyone? I'm waiting. Everyone?
Sir,
Yes?
Sir, I don't have my phone at the moment, so I can't send you a screenshot.
No problem. Send me afterwards.
Okay, sir.
Okay? But everyone else who have the phone in their hand, please draw that image properly with a scale and pencil and send me the screenshot. Whoever do not have that facility at the moment, keep it with you and send me the screenshot afterwards. Whoever have this facility right now, Ashraf, you have it? Ashraf,
Yes,
Ibrahim.
I'm right.
Okay, do that and send the screenshot. Ibrahim, you have it? Yes, Ibrahim. Do you have that facility? Mobile phone for the time being, so that you can take a screenshot and send it to me? Yumna,
I have to get the phone.
no problem. You will draw it. Once you draw it, just send me screenshot after the class. No worries. Ibrahim, please. Okay. Once you, every one of you, once draw that diagram, send it to me and give me go ahead, and we will proceed with the next topic. Then I'll give you 5 minutes to draw this diagram quickly. Select your own choice of angle, whatever angle you choose. This is your object. You will select any angle of incidence, but remember that it should follow the rule of reflection, which is angle of incidence must be equal to angle of reflection. Select any angle in one case, then select another angle, and your angle of incidence and reflection will be same for both of them. All right. Then you will, once you draw that, then you proceed it backwards on the other side of the mirror, and your image distance and object distance from the mirror will be same. All right. 5 minutes. Okay, students, you're done with the diagram?
I'm done.
You're done. Yumna, send it to me if possible. Otherwise, send it to me after the class, whenever it will be feasible for you. All right. Take a screenshot, send it to me so that I want to see how your work is. All right.
Okay.
What about Asjad? You?
Almost done.
Okay. All of you, you may send your diagrams after the class, no worries, but draw it right. Right. Yumna have done this. Ibrahim, what about you? You're finished?
I'm not sure I'm doing it.
Okay. Do it. And as I told you previously, anyone if missed something and, for example, do not understand, I already started my lectures. I mean, already started recording my lectures. Okay, so you can have the recording of a particular topic if you want it, and you can have it from the coordinator. Right. So by any chance, if you miss some of the class, or by any chance you do not understand, or you want to review the lectures, you can have get it from the our coordinator. You can speak to him, and he will provide you the particular lecture. Okay.
I just have to draw one ray reflecting.
Again, but
I have to draw one ray reflecting or two rays.
two rays. How can it be one ray? How you
No,
need to that one?
incident ray and reflected ray, one. And the second one also you have one.
Yeah, 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 absolutely. There is no other ray actually, because the point where they actually strike the mirror, that's where actually we will actually proceeded the both the lines backward, and that's where we believe that they are meeting. Because at the end of the day, you got the image, right? And when you get the image and actually the lines are not intersecting, then what we do, we have done in lens as well, that we proceeded it on the same side. So we did it at the back side of the mirror. Okay. Minimum requirement is you should have two lines which are coming from the object. Incident ray and reflection ray, then incident ray and reflection ray. Select your own choice of angle. No worries, whatever angle it should be. It can be any angle, but when you proceeded it backwards, it will meet at one point behind the mirror. All right, 2 more minutes, and then we end this chapter, and we will jump to a new topic, that is waves. All right, I've received one picture. Where who have sent me the picture?
I did.
Yumna, did you see one thing? Did you notice your object distance is very small, but your image distance is very long? Why is this? Try to minimize it as minimize possible as it is object distance. Your object distance is straight line. This distance is, let's suppose, if 2, that distance is very far, right? So make them right. This is the only thing. Otherwise, everything is right. So what you can do it in such a way that the distance on that straight line will be equivalent. That distance and that distance should be equivalent. All right, Yumna?
Okay, so I just shortened the intersection part.
Yes, yes. Shorten the intersection in such a way that both the distances are 101% equivalent. Because that's what our point is. That image formed by the mirror is, one of the characteristic was that they are equidistant. Object distance and image distance from the mirror is equidistant. Height of the object and height of the image is equidistant. One more point is there, that the distance which we are talking about of the object from the mirror is always at 90 degree. That is the reason I'm always saying that both the distances are perpendicular, right?
I'm sure I sent you the one I made.
Okay, I didn't receive yet. Where are you? Where did you send it?
I messaged you on your account.
but I didn't receive it. Send it again, or is it in the process of coming?
I'll send it again.
Please. Because I just received from Yumna.
Okay.
Hmm. Okay, guys, whatever diagram you have drawn, send it to me after the class if you're not able to send it now. We will start with the new topic today. It's all interconnection. So it's, yeah, I received it. Ibrahim, I just received it. Yes, absolutely right.
Okay.
Yeah, it is like that. But didn't you show the meeting? You have to show it with a dotted line, right? The line which is very, very light, you showed it. You didn't show it by a meeting, right? So show it by meeting, okay? Just show the
Okay.
intersection point at the back by dotted line, not
Okay.
with a dark line. I can see the lines which are very light lines, but show them with the dotted lines, a bit dark, but with the dotted lines. All right. Otherwise, the diagram is absolutely right. Absolutely right. Good work, Ibrahim.
So,
Okay. Now let's start with the waves. Okay. The
sir,
our yes, Asad.
after the reflection, the both lines, when the image is forming, they both are meeting at one point.
Yes, but at the back of the mirror, remember. And both the distances will be equal. Object distance from the mirror, and image distance of the mirror. And most importantly, both are just flipped, you can say. All right.
Okay.
Okay. Our new topic is wave. Anyone have any idea what is wave? Yes. Anybody? What is wave actually? Ibrahim, what do you think of a wave? What is wave? Yumna, you? Armina? Any ideas? Ashad? Anyone? No ideas?
The wavelength, crest and trough.
But you are talking about one specific wave, right? Now I'll let you know what is wave. All right. The first thing is, let's take an example of a pond of water, right? Or you can say we have a big beaker of water. Suppose now the words I'm using, it just memorize those words, or at least focus on those words. Let's suppose this is water. In general, whenever we are talking about, we talk about, yes, very good. Asjad, your diagram is fantastic. Great work. Good. This is the diagram you have to draw if they ask you to draw it from how to draw the image by using reflection. Good diagram. Okay. Now, important thing is, let's suppose this is your water inside the beaker or inside a pond of water, whatever. Now, point is, can I call it medium in general? Yes, I can. So this is your medium you're talking about. Okay. Now, important thing is, from now on, I'll be using medium because waves are normally formed inside the medium. Now, what exactly it is? Let's talk about that. Let's suppose that this medium is absolutely smooth. Can anybody tell me what is meant by smooth medium? Yes, students. What do you think of a smooth medium? Anyone? Yes, all of you.
Plane.
What is meant by plane? When I say smooth medium, what does it mean? Remember, when I say smooth medium, it means that are no ripples produced in the medium, and the water surface is absolutely plain surface. It's a straight surface. No ripples are formed inside the medium for the time being. It's going absolutely smooth. That's what it means. So no ripples for the time being. Now you start putting stones there. Now this stone which you are putting in, you are giving it energy, right? So when you're providing it energy, it will strike with the particles of the medium. One particle will hit the other particle will hit the other particle, with other particle will hit with the other particle. So in that way, energy is transferred, and that energy transfer will be shown in the form of a ripple, or in the form of ripples produced in the medium. So you will see a sort of a wave which actually moving in the medium. So you can say that wave is the transfer of energy from one point to another inside the medium. That is the first thing. That wave is a transfer of energy from one point to another point inside the medium. Second important thing is, when I say it was a smooth medium, it means you didn't disturb the particles of the medium. But as soon as you threw the energy, I mean, you throw the pebble or you throw the stone in the smooth medium, you disturb the medium. And when you disturb the medium, ripples start producing. So, another proper full-fledged definition is wave is a disturbance which is produced in a medium. So, it's a disturbance which is produced in a medium. So, what is fully definition now? Wave is the transfer of energy from one point to another point inside the medium, and it is the disturbance which is produced in the medium. All right. So, this is what the wave is. Now, how many types of waves you have? Types of waves. Any ideas, anyone? Types of waves? Yes, anyone? Types of waves.
Transverse and longitudinal.
At this point, I will stop you. When somebody will ask you types of wave, you have to ask him or her on the basis of what? Because the one you are telling me, they are on the basis of the shape, on the basis of the movement of particle, in which way the particles are moving. But the first one is on the basis of passing through the medium. There are two types of waves. One wave is called as mechanical wave, and the second one is called as electromagnetic waves. Now, can anybody tell me what is the mechanical wave? Yes, what is mechanical wave? Anyone have any idea what is mechanical wave? These are the waves which need medium to travel. Now, what does it mean is, for example, if you're talking about sound waves, you need air for that. Without air, if you even speak, nobody can hear you because there will be no sound wave. If you're talking about water wave, you need water to be there because if there is no water, there is no wave. So these are the waves which need medium to travel. Without medium, no waves. Example for the mechanical waves are sound waves, water waves. There can be more waves as well. Who will tell me what is electromagnetic waves?
So what is the medium for sound waves again?
Sound waves, air.
Okay.
What about electromagnetic waves? What are those waves? Yes. What is electromagnetic waves? These are the waves which do not need medium to travel. These are special type of waves which actually do not require medium. Can anybody give me example for these electromagnetic waves? The best example we will have it for this one is a light wave. Light waves are electromagnetic waves, or sometimes we call it electromagnetic radiations. All right. Now I can give you a very good example. You will understand it because you normally notice it. One of my question is why this is the normally the scientists are saying that on sun it was explosions every time. Every time there are explosions, blasts, and all this thing, and they normally reckon that if by any chance you receive the sound from the sun, we will be deaf in a moment. But the point is, you will receive a light from that far, but we never receive the sound from that far. What is the case? Why is that so? What is the reason? What do you think? Why we cannot receive the sound directly to our earth? Why you only receive the light rays? Who will answer that? Yes. Why we cannot hear the sound from the sun, but we receive only the light from the sun? Yes.
Because it has electromagnetic waves.
Yes. Simple as that. Light is an electromagnetic waves and it doesn't need medium to travel because in between the earth, I mean, in between the universe, we have no medium. We call it space or we call it vacuum, and vacuum doesn't have any medium. So light is actually passing through the medium because they are electromagnetic radiation, while sound needs medium, and that vacuum or that space do not allow sound to pass through because sound need medium to travel, and because sound need medium to travel, so we will not receive any single sound from that big giant sun because they are mechanical waves. All right. Now, once you understand that, on the basis of shape of the wave, we got two types of waves, which Armina already said it. One is called transfer waves, and the other one is called as longitudinal wave. All right. Any problem?
No, sir.
Transfer waves and longitudinal waves. Everybody copied?
Yes.
Okay. Now I'll show you a diagram there first, and then I'll take you back to okay, that diagram. Three waves. Slow. Okay. Now this diagram. If you see this diagram here, don't worry about what is written on the top because that will confuse you. Okay. Now transfer waves is what kind of wave is transfer waves? Okay. That's what the thing is all about. Can you see that wave which is right in front of you? That wave in the blue and then the red. So basically, let's talk about transfer waves. First of all, I will draw it and then we'll see what kind of waves are these. This is your wave and we called it transfer waves. Can you explain that, anyone? What is transfer waves? They are like going up, then going down, then going up, then going down, then going up, then going down. This is called transfer waves. X-axis is your time domain and y-axis is your displacement. We will talk about this in a minute. But what is this wave and how to explain that? This is transfer waves. This is the direction of the wave in which wave is moving, right? So how do you explain that? Anyone? Yes. Anyone have any idea? Armina? Beta, you have any idea? What is transfer waves? Hello? Anyone? Okay. Now, if you see there, the first thing is first. This position, which is a straight line, is a position we give it a name as rest position. Or you can call it equilibrium position. Or there is another name, mean position. This is a position when there is no wave produced in a medium and your medium is going absolutely smooth. All right. Now, important thing is that your wave is going up and down, up and down, up and down, and moving on the right hand side. But the particle of the medium going up and down from the mean position and from the rest position. So remember that the wave in which particle of the medium travel perpendicular to the direction of the motion of the wave. So wave in which particle of the medium travel perpendicular to the direction of the motion of wave, that type of wave is called as transfer waves. If you check this out, you can see yourself the direction of wave is on the right hand side while the movement of the particle is up and down. So if you if you just draw a line that is a movement of particle and the movement of the direction of the motion of the wave, you will find out the angle between both of them is equal to 90 degrees. If this is the angle and this is how the particles are moving, We call that kind of wave as transfer waves. Anyone have any question in this? Hello?
So what do you mean when you say travel perpendicular to the direction of the motion of the wave? Like they just, what do you mean by perpendicular to the direction?
Very good. See that. If you check the particles here, particles are going this way, right? It's on the wave. Whenever you see that, if this is your standard rest position, the wave motion is this way, right? It is propagating this way, like this. But particles are going perpendicular from this same way here, same way, this way, this way. This is all perpendicular from the position that we call it rest position. But the motion of the wave is on the right hand side. It will continue on the right hand side like this. But particle is going up and down from the rest position or equilibrium position or from the mean position. So technically speaking, particles are not going anywhere. I already spoken that remember that particles are not moving anywhere of the medium. They're just moving up and down, to and fro movement. But energy is transferred from left to right. So particle moving up and down and energy transfer from left to right. Between both of them, the angle is 90 degree. Yes, Ibrahim. Now you understand what I said?
Yes, sir.
Good. So that type of wave is called as transfer wave. The best example for the transfer wave is light waves. Light waves are transfer waves. Okay. So these are your transfer waves. Even though they are electromagnetic, but they are transfer waves. Now, to understand these waves and everything, we need to know some of the properties of the waves, which are in our course, or you can say some special terms which are in our course. Now, what are those terms? The basic terms related to the. Now, what are the terms? First thing is displacement. What is meant by displacement in case of the waves? Who will tell me? Yumna or Armina? Any one of you? What is meant by displacement of the wave? Or Asjad or Ibrahim? Anyone? No one? Okay. Displacement is simply, now if you see, these are the basically particles on the wave, right? They are just these particles. They are going up and down with respect to the mean position. So their movement with respect to the mean position or from the equilibrium position is called as displacement. If you see the displacement, this is vertical distance. So you can say the vertical distance of the particle of the wave from the mean position or rest position. This is what we call as displacement. The SI unit of displacement. Yes, who will tell me what is the SI unit of displacement? SI unit of displacement is, yes, what is it? Meters. How do you explain mean position or equilibrium position? Yes, what is mean position or equilibrium position, or you can say rest position? Who will explain that? What is it? Anyone? Ibrahim, Yumna, Armina, Ibrahim, Ashad. Why are you so quiet now today? Nobody's participating. Hello?
So we haven't discussed longitudinal waves yet.
No problem. First, we have to discuss this transfer waves. And once the transfer wave will finish, then we'll jump to longitudinal wave because longitudinal wave themselves are a separate topic. We have to discuss all the terms in longitudinal wave as well. Okay. So once we finish with transfer wave, we will come to longitudinal. Okay. So the main position is the position at which there are no waves produced in the medium is called mean position. Okay. So mean position in that case is the diagram. If you see, this is your mean position, the straight line. Horizontal straight line is your mean position. We already see that. Now, what is amplitude? Armina, what is amplitude? Amplitude. Who will tell me what is amplitude? In this diagram,
Sir, how big the waves are?
again, what?
How much distance there is between the waves?
No. It's not the distance. See, when we were talking about the displacements, we say how much displacement your particles are moving with respect to the mean position, right? Now, the maximum displacement from the mean position is called as amplitude. So the particle which is actually sitting here or the particle which is sitting here, they have a maximum vertical displacement. So maximum vertical displacement is called as amplitude. So you can say maximum vertical displacement from the mean position is called amplitude. Unit of amplitude is also meters. SI unit is meters. Now another thing, crust and trough. Who will tell me what is crust and what is trough? Yes, what is crust and what is trough?
So crest is the highest point of a wave.
Crust is not the highest point. Crust is the upper part of the wave, while trough is the lower part of the wave. This is your trough. This is your crust. So you can write here the upper part of the wave from mean position. The lower part of the wave from the mean position. Okay. So crust is the upper part and trough is the lower part. Now another thing. What is meant by time period? Who will tell me this? Time period. Yes. What is time period in case of these waves? Anyone?
How
What is
long the waves are being recorded for?
waves or wave?
The waves.
Remember that first of all, you are talking about one single wave. One single wave means one crust and it's one trough. Like this one wave means one crust along with a trough. So your one wave started from here and it ended up here. So basically, now you're right. Time required to complete one complete wave. The SI unit of time period is seconds. Okay. Now, when I say wave, remember that wave means one crust along with the trough. So, one crust and one trough means one wave, complete wave. Okay. What about frequency, guys? What is frequency? Yes, frequency. Who will tell me the frequency? Anyone have any idea what is frequency? Remember that when you're talking about a frequency, it means that number of waves passing from a point in 1 second. So number of wave passing from a point in 1 second is called as frequency. The formula for the frequency is F is equal to number of waves divided by time. Its SI unit is hertz. That is the name of a scientist. We normally represent it by Hz. Its actual unit was 1/second, or in other words, second inverse. But we give it a name. The scientist, his name is Hertz. He give it a name Hz or Hertz by his name. Students, any problem till here? Anyone? Any questions?
No.
Ibrahim, you, Yumna, you, Asjad, you.
So, sir, the unit of time in this formula is hertz.
No, not unit of time. It's a unit of frequency.
Okay.
Time unit is seconds. Okay, now because we are ending the session, so let's quickly ask me a question. What is wave? Who will tell me what is wave? Yes, what is wave? Who will tell me?
Transfer of
Yes,
energy
Asjad.
from one point to another point.
Absolutely. It's a way of transferring energy from one point to another point, and definitely it's a disturbance which is produced in a medium. Yumna or Armina, what is meant by mechanical wave? Yes, what is mechanical wave? Ibrahim, mechanical wave?
Sir, mechanical waves require a medium to travel through.
Okay, and what about the electromagnetic waves?
They don't require a medium.
Okay, that's good. Example of any electromagnetic radiations or waves?
Light waves,
Light rays. And now what are transfer waves and how do they move? Yes, transfer waves. Transfer waves are the waves in which particle of the medium travel perpendicular to the direction of the motion of the wave. Okay. And then we have these terminologies one by one. We have done that. So students, I want you to go through this till the next lecture, and hope to see you in the next lecture, everyone. Okay? Take care, everyone, and bye. Allah Hafiz.
Allah Hafiz.
Allah Hafiz. Take care.
Allah Hafiz, sir.
Allah Hafiz. Allah Hafiz. Let's say Allah Hafiz to you.